I'm not sure, maybe I missed it, but what would the world be like such that it would be inhospitable to life if the cosmological constant, this universal repulsive force, were of different values?
Okay, let's suppose it had what I might call a natural value, comparable to other mass densities that occur in the basics of physics. What are they? Well, there's this Planck mass density. If the cosmological constant was anywhere up near that, the universe would expand so fast that it would never ever have a chance to let anything significant happen. It's kind of curious if you understand the exponential growth of the universe. You might think that what you would see surrounding you is everything growing exponentially. That's not really true. I cannot explain why this is. It's the properties of something called de Sitter space. The faster it expands, the smaller your universe would appear to you. The more tiny it would appear. I can explain why. The portion of the universe that you can see is the portion in which things are moving away from you at less than the speed of light. Anything that's moving away from you with greater than the speed of light, you can't see. Okay, the bigger the cosmological constant, the faster the expansion, and the closer in would be that place where things are moving away from you with the speed of light. The region that you could see gets smaller and smaller as the cosmological constant gets bigger. The result would be, if the cosmological constant were terribly, terribly much bigger, the region, when I say that you could see, the region that would be the universe to you would be so small that it couldn't contain a proton. So a very big cosmological constant would be, and it doesn't have to be very big, maybe 10 times larger than the value that it has. The universe would have expanded so fast that galaxies, stars and so forth would not have had time to form. Okay, so the universe would be without stars, without galaxies, just a different place if the cosmological constant was much bigger. If it was as big as it could be, as big as the Planck mass density or something like that, effectively the universe would expand so fast that everything would be moving away from you faster than the speed of light, and the portion that you could see would be this tiny, tiny little region, vastly smaller than a proton. That would be your universe. You wouldn't be you, of course, but so yeah, that's the situation.